Okay, I wanted to start out with just a little bit about what's the rationale for using cover crops. And basically, it's to have a living, growing plant at times of the year when we typically don't have anything living and growing. And the idea is to take advantage of the opportunity that we have to photosynthesize, fix carbon, feed soil organisms, recycle nutrients, protect the soil surface, and basically make better use of the time and the resources that we have available. Another way of thinking about it is to look at a photo. This was at the Purdue agronomy farm a couple of years ago where we had admittedly a very early harvest, but this was September 1st. Soybeans on the left, corn on the right, harvested and brown. Okay, brown all of September, brown in October, brown in November, brown all winter, brown in March, brown half of April. On the other hand, the grass strip between those plots, this wasn't a cover crop, it was just the grass growing in the alleyways and on the fence rows and so on, green. Green and photosynthesizing all of September, October, November, sometimes even part of December. Green again in March and April. So we're fixing carbon, sequestering carbon in the soil, feeding the organisms, building soil aggregation and tilth, recycling nutrients, keeping those nutrients there as opposed to leaching away. So again, just a way to make better use of the resources that we have. We may not have enough growing season left to prolong our cash crop growth, but we certainly have enough growing season left to do some improvement of our soils. And so that's basically what we're looking at. Cover crops, of course, are part of a system. There are different potential benefits and different challenges for every cover crop. There's no one cover crop that's going to meet all needs that folks might have. Also, as part of a system, cover crops, the rest of the system also needs to have some adaptations. If a grower is interested in just throwing cover crop seed out there and not changing anything in the system, not even one little speck, they're probably not going to be successful. Right? There's going to have to be some tweaking of the rest of the system, nutrient management, pest management, and so on, in order to integrate cover crops successfully into a system. Okay, so how do you go about selecting cover crops? I suggest that people look at these kinds of questions when they're first thinking about what kind of cover crops they might use. What is your main purpose? In my view, that's the first thing that folks ought to consider. What is it that you want the cover crop to do, to accomplish in your system? What is your current cropping system and your current tillage or no tillage system? Current cash crop, next cash crop, tillage, no tillage. What time windows are available? How are you going to seed the cover crop? And how are you going to terminate the cover crop? And then a whole host of specific things like soil types and climate, manure utilization, and so on. The ones that are highlighted in green there are the Midwest Cover Crops Council, or MCCC selector tool, can help with those, and I'm going to talk about that just a little bit later in the presentation. So what I'm going to do now is go through a couple of slides talking about some of those potential benefits of cover crops. And again, you may have heard some of this morning. Nitrogen scavenger, that happens to be the one that I've worked the most on in my role looking at water quality. But a nitrogen scavenger is basically a cover crop that's going to take up nitrogen or trap nitrogen that's residual in the soil, whether that's leftover fertilizer or whether that's nitrogen that's being released from decomposing residues or just general mineralization in the soil. The idea is to save that nitrogen for later use by a cash crop. It might be this coming year, or it might be a couple of years down the road, but nonetheless to put that nitrogen in the bank so that a succeeding crop can use that, and to decrease nitrogen loss to drainage water, which is a big benefit for water quality. On the other hand, maybe somebody's looking at wanting a nitrogen producer, in which case they obviously need to have a legume. The fact that we've split these out does not imply that a nitrogen producer does not scavenge nitrogen. Most of you know that legumes will scavenge nitrogen before they fix a lot of their own, But if your main purpose is to scavenge nitrogen, then you're probably not going to select a legume because it's just not very good at it. There are better choices if scavenging is your main choice. Maybe the reason that somebody wants a cover crop is the traditional reason of reducing erosion, okay, whether that's water erosion or wind erosion. Still a very valid reason to use cover crops. Maybe somebody's really interested in improving soil health, and I know that this morning there was a major emphasis on that. Building soil organic matter, increasing biological activity and diversity, improving aggregation, building permeability and macropores and water flow in the soil, and buffering the soil from variable weather. Maybe the main purpose for somebody is to conserve soil moisture, to have a really good mulch on the soil surface so that you reduce evaporation and have more moisture available for the crop. Maybe it's to recycle nutrients. Maybe weed control and pest suppression is a major goal, in which case you're going to, again, want a different kind of cover crop than if your major goal is to scavenge nitrogen. Maybe it's extra forage, okay, and we'll talk a little bit about that with our later speakers. But whatever the purpose is, I think in all cases, what we're trying to also do is increase crop yields over the long term, not necessarily this year or this first year, and to decrease the year-to-year variability that we have and basically make our systems more resilient to the climate stresses that we have. Okay. Cereal rye is probably one of the most commonly used cover crops because it can be planted quite late and it's very winter hardy. And I know my other speakers are going to be talking about individual cover crops, but certainly you've all probably seen that. One picture to just illustrate kind of a no-brainer type of situation for cover crops. This is from my colleague Tom Casper in Iowa, but it's corn silage ground, and on the right, this was a photo in early May. You can see the soil is bare, crusted, eroding. Nutrients have been leached out. The soil microorganisms don't really have any food to get them going. On the left, you've got a nice rye cover crop exuding exudates into that soil, feeding the organisms, building soil aggregation, recycling nutrients, and protecting against crusting and erosion. If you go to, those of you who have been to other cover crop conferences or meetings, you'll usually see some pictures of tremendous amounts of cover crop growth and some very large cover crops, and that's all great. But sometimes you don't get quite so much growth, but it still can be beneficial. So this happened to be at southeastern Indiana at one of my drainage research sites. And in this case, we aerially seeded oats and oilseed radish into a standing crop of soybeans in mid-September, which was, that particular year was probably about a week later than would have been optimal for that system. But on the left, just kind of looking out across the field, you can see we have, decent stand, decent green cover there. And on the right, looking straight down, you could see the oats, you could see the radish. I'd call it relatively modest growth, but we were still having some benefit on our soil. You could see also that the soybean stubble from the no-till. This gets people a little more excited. In this case, the farmer here had wheat as the cash grain, harvested the wheat in July, applied manure, and then seeded a mixture of radish and annual ryegrass. This was the day after Thanksgiving that year. We went out and you could see tremendous amounts of growth. Some examples of the radishes from pencil size to carrot size to a little larger. Not the huge, what I call state fair radishes, 4 foot long and 8 inches diameter. But as far as the soil is concerned, I think these are actually more beneficial. And what I'm more excited about is what's underneath that tuber. Okay, in this case, my grad student, as we were pulling radishes, this one had a couple feet of the radish taproot that came along with the tuber. So if you imagine that whole field full of those radishes and all those taproots going down, that's a tremendous asset to permeability and to the ability of next year's corn crop to be able to grow down there. Another concept is, are you looking for primarily roots or are you looking for primarily shoots? Sometimes, again, growers get discouraged if they see just 3-4 inches of top growth, but many times that's fine because of the amount of root growth. Obviously, if you want forage, then 2 or 3 or 4 inches of top growth isn't very good. But if you're looking for improving soil health and improving soil permeability, the root growth is probably more significant. So just again, there's a trade-off there between roots and shoots, and you can't judge a cover crop only by what's on the top, again, depending on what your purpose is. Okay, this is kind of my depiction of the cycle of the year that I use to illustrate the nitrogen scavenging part and the water quality benefit part. So along the top there, the rationale for cover crops for water quality. Again, I work primarily in corn soybean country, but our corn soybean or any summer annual crop is normally fallow from October through April. But it's at precisely that time when the majority of our drainage flow occurs. Whether you have tile drainage or whether you don't, the water is moving into and through the soil and out the bottom. Okay? The majority of that happens precisely during that fallow period. For my particular site in southeastern Indiana, CPAC, 80% of the water that flows through that soil profile out the bottom occurs in November through April. And since that water is what's carrying any residual nitrogen, that means that 80% of the nitrogen that goes out the bottom is lost precisely during that period. Okay? It's not 80% of the nitrogen that we use, but 80% of what we lose out the bottom is lost precisely during that winter time period. And I want to clarify before anybody misinterprets this, we do not put our nitrogen on in the fall. This is spring-applied nitrogen, but basically we're saying that because all of our water flow is occurring November through April, that means any nitrogen that goes out the bottom is also being carried out the bottom at that time. That's nitrogen that's residual from last year's crop. It's nitrogen that's from decomposing, if it's soybean year, decomposing residues. It's nitrogen that's just being released as the soil organic matter is decomposing. Okay? So our summer annual crops are leaky systems, and if we have nothing growing, it just keeps going. Okay, so the idea with a cover crop is that by having something growing in September, October, November, maybe even December, it's taking up some of that nitrogen. Those live roots are taking up that nitrogen and reducing the amount that's going to be lost out the bottom. And then if it's a cover crop that actually overwinters and grows again in the spring, it's going to actively take up some additional. Okay, so this is the rationale for both improving water quality and saving some of the nitrogen that would otherwise be lost to the farmer, okay? Whether that's 20, 30 pounds or whether it's more than that if it's got manure in the system. Okay, so some common cover crops. You're going to hear a lot more about that from our other three speakers. Just in very general terms, the grasses are excellent nitrogen scavengers. Some typical ones that have been used, at least in the humid part of the Corn Belt, cereal rye, annual ryegrass, oats, wheat. The legumes, some typical ones that have been used include crimson clover, Austrian winter pea, hairy vetch, and red clover. And then the brassicas are excellent nitrogen scavengers. They're a little newer as being used, again, at least in the eastern Corn Belt, they're a little bit newer being used as cover crops. Turnips, of course, for grazing have been around for a while, but the daikon radish is one that's really been caused a lot of excitement because it's new and different, and you can get a really big radish. Okay, I'm going to talk just a little bit about those nitrogen scavenging crops. How much do they, the question is, well, how much do they scavenge? And then how much do they give back and when? Okay, well, how much they scavenge depends on, first of all, how much is there to be scavenged. Okay, if there's very low nitrogen in the soil, they're not going to scavenge much. But the amount of biomass produced is key to that nutrient uptake. Okay, so you have to get a decent stand and you have to have relatively rapid growth for them to be able to scavenge. Now, how much is released and when is it released? The age and stage of the plant when it's killed is going to determine its nitrogen percent, its carbon-nitrogen ratio, its other plant components. So all of those go into how fast it decomposes, as well as, of course, the weather. So I've said they're a huge challenge, meaning it's a huge challenge to be able to tell somebody ahead of time how much nitrogen they're going to get back out of their cover crop and when. Okay? So that's a research need. Okay, carbon-nitrogen ratios, just very briefly, this is one of the ways that we try to at least qualitatively get at whether nitrogen is going to be tied up or released and how quickly. So this particular table here, if you're looking at the microorganisms themselves, they have a narrow carbon to nitrogen ratio. If you look at legumes, and hairy vetch is the one illustrated here, it also has a narrow carbon-nitrogen ratio, about 11 to 1. The benchmark is a carbon-nitrogen ratio of right around 25 to 1. If you have a material that's about 25 to 1, it's not going to tie up nitrogen significantly, but it's also not going to release significant amounts of nitrogen. If it's lower than 25 to 1, it'll decompose quickly and release a lot of the nitrogen, not all of it, a lot of it. If it's higher than 25 to 1, when the microbes try to decompose it, they're going to tie up nitrogen, okay? So if you're using, so for example, rye, when it's vegetative, nice small material, is right at that kind of break-even point. Not really going to do much either way, okay? Rye, if you let it start to head out, is going to have a wider carbon-nitrogen, 37 to 1. If you let it get even older, it's going to be even higher. So as it decomposes, it's going to tie up nitrogen. Wheat straw, corn stover, and newspaper just as kind of a benchmark for you. So if you're going to use covers that have a wide carbon-nitrogen ratio, then there's a couple of suggestions. Number one, you should allow time for decomposition to occur before you plant a crop that needs a lot of nitrogen, like corn. Or you should apply extra starter nitrogen to give that cash crop a good start. Or don't choose high carbon-nitrogen ratio covers before corn. We have many very successful farmers who successfully use cereal rye before corn, okay? But you have to really have done your homework, know what you're doing, know how to manage it, and so on. If I'm talking to somebody who's just getting started with cover crops, that's not usually what I would recommend, okay, because of the management issues of a potentially high carbon-nitrogen ratio material before a crop that needs a lot of nitrogen, including early on. Okay, so going back then to how do we select cover crops? What is your main purpose? That's kind of what we've talked a lot about that. What is your cropping and tillage system, the current cash crop and the next cash crop? I've talked just a little bit about that related to carbon nitrogen. Certainly what's your tillage system is very significant. I'm not going to talk about that today. What time windows are available, how are you going to seed it, and soil types. Okay, the green ones, again, as I said, are the ones that our MCCC tool can help with, and I'm going to go through just a couple of screenshots of that. The current first generation Midwest Cover Crops Council tool does not help you at all with saying, does this crop make sense before corn or before soybeans, okay? What it helps you with is the time windows and the main purpose and the soil types and climate, okay? Keith's will help you a little bit with the carbon-nitrogen issue. I think you all got this in your satchel when you registered. It's an excellent book from SARE, Managing Cover Crops Profitably. It has lots of detailed information about a lot of different cover crops. Its limitation is that it's national in scope. So that means that the rankings that it has in there are very general, and the ranges of growth are very general because it's a national book. So in the Midwest Cover Crops Council, what we've tried to do is for the Midwestern region, we've tried to do those rankings for our region and to really compile information together for our region in one place. I encourage you to check out our website sometime. We have added a few more states on the western edge and Missouri as well, so we've pretty much rounded out the eastern part of the Corn Belt. And if you go down here to the cover crop selector tool, that is functioning for all of the states that are shown on that map right now. I'm going to show you 3 slides. The first thing you do is you put in your state and your county. Okay, so again, ranging from Ohio through Minnesota, Iowa, Missouri, it's functioning. You put in your state and your county, and that brings up the frost date information, the long-term frost date information for your location. Okay, it's the 30-year normal. So obviously, some years frost comes earlier, some years frost comes later. And it brings up all the cover crops there on the left-hand side, the non-legumes, the brassicas, the legumes. And then when we first designed this project about 3-4 years ago now. We just put in some example mixes. This was not at all to say these are the only mixes available. We simply wanted to show some examples. The green bars here are saying for your county, when is the reliable establishment time for that cover crop. So for buckwheat, for the particular county I have here, Henry County, Illinois, this is saying it can be reliably established between May 15th and August 20th or so, okay? So it's pulling up local information. You can stop right there if you want. It's basically just saying when can you generally get that established. But if you go a couple steps further, you get more information. Here I simply put in when I anticipated planting the corn and harvesting the corn. And all it does is put a blue shading on it. So all it's doing is reminding you as you're working through this that, you know, I got a corn crop in the field, okay? So if I want to seed a cover crop and I am not prepared to do anything before harvest, right? If the way I'm going to seed it is to drill it after harvest, that's what I have available, then my choices are pretty limited, okay? Basically, we've got the ones that you have seen the most often, okay? Cereal rye, winter triticale, and winter wheat, okay? Because they can be planted late and still be successful. However, if I decide, you know, I really want to put in annual ryegrass, or I really want to put in spring oats, well, the green bar is totally covered up by blue shading, but if I'm prepared to aerially seed or high clearance seeder or something else, then I could still get that established. Okay, so it's just again letting you know that if you want to use those crops, you've got to do something other than waiting until harvest. The yellow bars are giving you a little, you know, if you really want to push it, you're kind of given a frost risk there. And then the red bars are for some of those cover crops that regularly get frost seeded when you might do that. Okay, but then the real purpose of the cover crop selector tool is to help you select something that meet the purposes that we spent time on at the beginning of the talk, right? So here I said I want my cover crops to be a nitrogen scavenger and a soil builder. So each one of those cover crops is ranked for all of the different purposes, excellent, very good, good, fair, and poor. It has to rank at least good to stay in the screen here. So you can see that almost all of the legumes dropped out because they're not very good nitrogen scavengers. So again, if I want a nitrogen scavenger, they would not be a good choice. Okay, you can also get a printout of any of those cover crops that talks about seeding date and rate and depth and cautions and things like that. Okay, I tell farmers that I can't tell you what to grow because, of course, it depends on what you want to do. But when pressed, there's a couple of things I might recommend. My current favorite is oats daikon radish mix. It's good after soybeans, before corn, or anything that comes out just a little early, or you know, if we have a bad corn crop and it comes out really early. They're excellent nitrogen scavengers and they winter kill. So for somebody who's just starting in cover crops, or even for somebody who's done cover crops but doesn't want to mess with green growing material in the spring, it's a good choice, okay? Before soybeans, after corn, cereal rye is still great, and even if it starts to get really big in the spring and ties up nitrogen, doesn't matter because the soybeans fix their own. Another choice might be adding some diversity to that, and I know Dave and Gail, I think, will talk more about that. But if you really are focusing on soil health, it's nice to think about at least a three-way mix, so something where you have fibrous roots to really help aggregate the soil, something that fixes nitrogen, because if you're going to build soil organic matter, it has to have enough nitrogen to build the organic matter, and then a brassica to add more diversity. Okay, just a couple more slides. I'm going to skip that one, actually. So I think the potential impacts, again, I know this conference is national. The potential impacts of cover crops are huge, particularly important in the Midwest where we haven't used them quite as much, for soil health and crop productivity, to conserve our very expensive land, to improve water quality, and to improve resilience to stresses from climate variation for long-term sustainability. So while Dave is coming up, you all got the Cover Crops Pocket Guide from the MCCC in your satchel, and I encourage you to check out the website. you.